everyone, this is Group 9. My name is Kasha Alvin Sali, and our project title is Generative Attention-Based Mechanisms for Fake Currency Node Detection. And our creative project title is GraphCAD Fake Currency Node Detector. And the keywords in this project are graph attention networks, generative adversarial networks, image distillation, vision transformers, and feature extraction. So, as we all know that fake currency has proved to be a menace to most economies, and the devised methods that were brought up that included traditional methods such as money inspection and UV light-based techniques have proved to be slow, error-prone, and some of them require specialized equipment. But then with emerging technologies, we have seen that counterfeiters have improved their techniques and then come up with more advanced and confiscated forgeries. And this has required need for an advanced and automated solution to ensure reliable fake currency node detection. So fake currency has posed a significant threat to economies, leading to financial losses, and then of course reducing public trust in monetary systems. But unlike traditional detection methods, AI-powered solutions such as the GAT, the Graph Attention Network, provides a scalable and accurate approach by analyzing a complex or intricate banknote features, and then implementing such a technology would enhance security to then prevent financial fraud and then strengthen economic stability. The project objectives were we ought to develop an AI-based detection model to classify real and fake currency notes, improve detection accuracy for of fake currency notes, and of course reduce dependency on the traditional methods such as money inspection by automating the detection process. Well, for the solution overview, our fake currency detection approach uses a GAT, Graph Attention Network, to analyze currency features, and it uses, at first we use ORB. It is oriented first and rotated brief as a feature extractor to get key points out of the sample image or currency note, and then graph construction of done by the diagonal triangulation for the key points. After that, the graphs are fed into the GAT that applies its GAT conventional layers and focuses on the critical security features, which has ensured robust and accurate counterfeit detection. Then the innovative aspect of all this is that we have an integration of the ORB key point extraction with the ordinary integration that creates a robust feature set that preserves the actual structural integrity of the currency note. And then after that, leveraging the GAT on that robust feature set has the dynamically prioritized key features, and then of course enhanced accuracy. The flowchart for the approach is just simple. You input a currency image, key point extraction by the ORB, then graph construction by the diagonal triangulation, and then the feature set is fed into the graph attention network that carries out feature aggregation, and then using also its attention mechanism, and then gets out a prediction or classification of real or fake. Then the data used was obtained from a public repository on Git. Image processing techniques we use there to first resize, and then also some noise reduction. The data set was including dimensions of 500 Indian rupee, as you could see, and then also the 2000 Indian rupee. And it's just a class distribution of the data in the data set. Then the models and techniques, we developed quite a number of models, at least 10. And then you could see from this, we implemented learning rate, as you could see, from 0.1, 0.01, then 0.001. And then these are just accuracy scores, but as you could see, the best performing flow was the GAT V8 and then noise distillation. And then you could see how the accuracies were increasing by the learning rate. And then the reasons for choosing the models, this was just because for the accuracy, we just choose the GAT and then also feature extraction. Also, the V8 was also excelling at detecting some of these intricate counterfeit patterns. Then we also applied GANs just because we are facing an issue of scarcity of fake currency notes. So the GAN helped us mitigate such. Then the system architecture was just as simple. The user uploads an image, the API sends a request to the backend, and then the backend carries out the data preprocessing, feature extraction by ORB, and graph construction by the diagonal triangulation fed into the GAT. Then the GAT applies its attention mechanisms, then carries out a prediction, real or fake, then it's fed back to the UI, back to the user. And then the implementation details use Python language, then libraries, frameworks, you would use TensorFlow, PyTorch, Scikit-learn, OpenCV, and NumPy. Then the platforms were Google Colab, Render for deployment, and GitHub. results and evaluation. The results were as this, as you could see, the scores again such as a precision recall, fund score for the 10 models, and then the best performing through the graph, V8 and registration, the worst performing were the efficient and MobileNet, and then VBraceNet. This training loss was for the gut training that how the training loss was varying by the number of epochs and because it was dropping significantly. Then a confusion matrix was for the gut as well. The correctly classified 6 instances of real as real, real nodes, and then 5 as fake real nodes as 5.
Present the impacts and relevance of our project, which is about fake currency detection using graph attention networks. My group mate has already talked about the previous slides, and I'll begin from the impact and the relevance. To begin with, the impact and relevance of our project, I'll begin by talking about the Ugandan setup, and then after I'll talk about the international setup. On the Ugandan setup, we are having combating counterfeit money, and our system helps banks and financial institutions quickly identify fake notes, thus reducing fraud. And then on international stage, you are having, of course, we know every country has compliance issues. So many countries have strict regulations on counterfeit detection. For example, we know that there is Interpol, there is Europol, and all these agencies have been put in place to make sure that this system aligns with the global anti-fraud standards to ensure compliance. And then the targeted users of our project, who are the beneficiaries of our system? We are having banks, financial institutions, government agencies, public, and other businesses, from retailers, because we believe all these people deal in money every day. And then we are having the relevance of our project or of our system to the SDGs, which are the Sustainable Development Goals. It's relevant in the SDG number 8, SDG number 9, SDG number 17. SDG number 8 briefly talks about decent work and economic growth. Of course, we know due to inflation, which is brought about by this fake currency in circulation, it hinders economic growth. And then SDG number 9, which talks about industry innovation and infrastructure. We believe that all these things that I've talked about, industry innovation and infrastructure, are facilitated by finance. So if this finance is altered in form of counterfeit currencies in circulation, it means that all these things won't take place. And then SDG number 17, which talks about the partnerships for the goals. Now, for example, I'd said in the previous slide that these partnerships, in form of Interpol and Europol, they work together to make sure that they cap down this counterfeit currency circulation. And then, if I'm talking about the intellectual property and innovation of our system, we shall talk about Isonavity. Isonavity is about us implementing the graph attention network. So of course, we believe this thing has never been implemented across the web. We searched across the web and it has never been implemented for fake currency detection. What makes our thing special? This one, it's in the form of, it's our own invention. And it being an invention, it gives us the patentable aspects. What are our patentable aspects? Our patentable aspects, first of all, is the model itself, and then the unique preprocessing pipeline, which uses ORB and the dictionary translation. These two things give us a unique processing pipeline. And then also we're having the real-time Flask API. Of course, we know that many APIs have been implemented, but then our API is specifically for fake currency detection. We believe it's also an invention on its own. Then we are having the cooperative aspects. These ones are just put in place to make sure that they safeguard our work from distribution and reuse by other people that are concerned. Examples include the Flask API code. We are having the GATT model implementation, our codes. Then the training scripts, which are the codes we pushed on GitHub, and the documentation, which involves the concept paper that we wrote. So all these are copyrightable and we have ownership to them. Then the monetization and scaling. Of course, I'll be talking about commercialization. How shall we benefit from this? And what are our revenue streams? We are having the B2B, which is the business to business as model. Of course, we believe our system, we shall be benefiting from it through subscription from banks and financial institutions that are willing to use our our system. And then we also have the API integration, whereby we shall be charging those people who want to use our APIs. For example, all fintech platforms and the ATM manufacturers who want access to our services, we shall give them the API, and then in return they'll pay us. Then the potential market size in relevance to Uganda, we believe that our market size is being used by the banks, forex bureaus, and other large businesses which handle cash transactions. And then in Africa, if I'm to view it from the long-term perspective, we believe that over 400 commercial banks in sub-Saharan Africa could benefit from automated counterfeit detection. That's in the long run. And then the SWOT analysis, which specifically defines the strength, weaknesses as external features, and then opportunities and threats as the internal features. I mean, it's the other way around. The strength and weaknesses are the internal, then the opportunities and threats are the external. Of course, threats are always a competition has to be a threat, and then high demand from banks has to be an opportunity. Then using a gut model, this is novel. This has its own novelty and it's a strength. And then the weakness contains has a recurring high quality training data for our model. That's a weakness because it's within our setup, it's internal. And then the system demonstration, which demonstrates our UI. We use Render to deploy our system using the Flask API. So a user inputs, chooses an image. It can be a fake note, it can be a real note, or any other image. And then the task of this system is to see if this image is real or fake, depending on the image that has been given to it. So that's it. And then the team contributes.